So thank you very much for joining today's introduction webinar on Midas NFX 2012. And I am Cyprian from the Technical International team of Midas IT. Today more than 50 engineers are attending the webinar. So again, thank you very much for your interest. And after that, if you have some questions, please ask them in the chat section, and me and my staff will answer them at the end of this webinar. So first, let me introduce the work environment. After that, I will show you the analysis functions, and finally, I will talk about the pre and the post functions. So first, what is Midas NFX? Midas NFX is a multidisciplinary CAE solution which is totally integrated into one unique work environment. So here you have a view of the work environment, and I will show you into the software after that. The interface is composed of two modes. So you have the designer mode and the analyst mode. First, designer mode is more simple and provides an efficient way to import a CAD model and to perform all kinds of simulation design with various automated functions and minimal input requirements. After that, the analyst mode provides the tools you need to create complex CAD models directly into Midas NFX, and you have also more meshing and analysis functions. And in the two modes, you can use all the solvers of Midas NFX, the linear, nonlinear, CFD, etc. So after that, so I will talk about the workflow, which is very simple. In fact, in Midas NFX, first you have to import a CAD model. Then you apply some boundary conditions, some loads, you create an analysis case, and you obtain some results. And what is very interesting is that you don't need, when you modify your CAD model, you don't need to apply all the loads and do all that again. You can directly import the analysis case and do the analysis. So there is a very fast learning curve. There is a very intuitive workflow with minimum most operations, and I will show you that into the software by itself. So let me enter into Midas NFX, and first I will import the CAD model. Then I will apply a material to this model. So you see this model is quite complicated. It's an assembly. Let me show you the material color. In the worktree there is already one material which has been defined, and I will define another material using the very wide database of Midas NFX. So let's choose an alloy steel. It's already alloy steel. We'll change edit and choose a galvanized steel, and then I just drag and drop it on the parts on which I want to assign it, and it's done. Let's come back to the geometry color. Okay. Now that I have done that, I will have to simplify a bit this model because, as you see, there are a lot of small holes, fillets, which are very annoying for the analysis. So I just use the simplify function to find all the holes. So and then you can see all the holes in the model, and if you click on each one, it will appear on the model. Then I will select only the holes below 15 millimeter. Okay, select and remove. It's really simple. Same for the fillets. I will select the fillets below 25 millimeter So as you see here, there's a lot of fillets like that. So just have to select, remove, and my model is clean. You see no fillets anymore. Now I will assign the contacts between the parts. So I click on contacts, and after that I select all the parts, set the contact types. Here it's welded. Okay. You can view the contacts directly into the model worktree, and you can click on each contact to view it on the model. You can view also the slave and the master contact, which are in different colors. Now that I have done that, let's assign the boundary conditions to these two faces. So I will fix these two faces. So just boundary condition fix. And for the loads, nothing more simpler. I just select force, then -10. Okay. And if you want to modify that, you don't have to suppress and add again. You just select the load directly, right click, and by clicking on editing you can directly modify the value, or you can modify also the application point and thing. Okay, now let's mesh this model. First I will choose these two parts, right click, generate the mesh, and add these two parts are quite important. I will choose hybrid mesh, and I will increase a bit the number of elements here. Okay. These two parts are meshed at the same time, and you can view the meshing, which is very good. Now let's mesh the other parts. So I uncheck these two parts, and high speed tetra mesher. Let's increase the number of elements a little. Okay. And all the parts are meshed at the same time. And it's very fast also. So if on some parts the meshing is not so good, you can do again the meshing. You just select the parts. Let's select these two parts. Generate the mesh, and select the hybrid, and you increase a bit the number of elements, and it will remesh automatically these two parts, which with better accuracy. So it will take a little more time. And when I have finished the meshing, okay, I can create an analysis case. So let's create a linear static case, solve, then I save it somewhere, and the analysis is done in just a few seconds. Here you see 4.6 seconds, really quick, and you can view the results by double clicking in the worktree. So you have three types of results here: total translation, solid stress, and solid safety factor. You can add also some results. You can add any results. Okay. You can view different type of things, like the the deformation, the deformed shape in the undeformed shape. You can view also, for example, the minimum and the maximum. And if you want to see this information on each element, you can use the probe tool and just select the part of the model you want to have to know the value, and you can see also the minimum and maximum on each part. Clicking on each part, it will appear. Okay, and oh yes, I didn't show you the animation. So you can view the animation also in real time. You can view, for example, the stress, and you can zoom during the animation. You can change the view, so you can view the creation of the stress into this part. Okay, let's come back now to the PowerPoint. Okay, so when you do the analysis, sometimes you don't have the values for the materials, so it is always good to have a database of materials, and so you don't have to search all the values every time you want to do some simple analysis. And in Midas NFX you have the data from the mechanical, the heat transfer, the failure, and the fatigue values. Okay, let's talk about the analysis functions now. So as I said, Midas NFX is a total solution, and you have all the functions you need directly into the software and in one environment. You have the linear static, the modal, the buckling, the nonlinear, the dynamic, explicit, the CFD, and the most important is that all these functions are fully integrated in the same environment. You won't need to buy separately 5 or 6 modules to perform the analysis you need. You have also all kind of elements, the pyramid elements, the tetrahedral, the hexahedral. You have the 2D elements like the shell, the plane stress. You have the 1D element like the beam and the pipe, so really have anything you need. You can also use various types of loads and boundary conditions, like for example the remote load, the bearing loads, or the follower load. You can use also link elements like rigid links or bolt links. And so no need to say that using the bolt link will make you gain a lot of time if you have a lot of bolts in your model, like in the pictures here. So let me talk about the subcases also. Sometimes you need to perform one analysis with different type of loads or combinations, and you want to see the results of each load on the model separately. So you can use subcase to create a different case with another analysis with another load, just by dragging and dropping the conditions you want, and then when you solve the model, it will solve all the analysis together. The linear analysis in Midas NFX is very complete. You can perform the linear static analysis, the buckling analysis, or the modal analysis using all kind of meshes, and you can obtain quickly some reliable results with the 64 bytes high performance algorithms. Also, one of the good points is that you can use the linear contacts, like the sliding contact, into the linear analysis, and you don't need to do a nonlinear analysis costly in time to obtain the results you need. The second model here is not as simple as it appears also because of all the bolts, but again, in Midas NFX you can solve this problem in the linear analysis. Let's talk about the adaptive mesh analysis. So the engineers face a big problem when they are doing the finite element method. The meshing if the meshing are too big, then you will have bad results. If the meshing are too small, then it takes too much time. And to help the designers, the adaptive mesh function minus NFX can refine automatically the meshing in the needed areas. And also we have a function of auto-detection of the singularities to prevent the excessive fine meshing. The modal analysis in minus NFX, you can do, for example, using the subcase, you can do the prestress analysis, then you can do the modal analysis. You can use also the sliding contact, as I said. And as you can see in here, when you are doing a frequency response, the results you obtain are very different if you are using a normal sliding contact. The buckling analysis also can be done, and what is interesting to note is that you can use a subcase to perform first a linear analysis and then see the results of a buckling analysis on the deformed shape. Because as you know, the loads deform the structures, and the model characteristics of your model can change after the application of the load. So this is why this function is needed. The heat transfer, the thermal stress analysis is very complete also. You have nonlinear heat loads like the radiation. You can use the cavity radiation or not. I will talk about also a very special feature, which is the temperature sensor. In fact, it helps you to note the evolution of the temperature in function of the time, and reversely you cannot note when any temperature has been reached. For example, when it reached 60 degrees, when it reached 90 degrees, and it's important to have this kind of information when you need to know the exact time. Also, the other very interesting thing about this sensor is that you can use it to stop the analysis when the temperature has reached a certain value into your model, and so you don't lose any time to wait until the end of the analysis. We have also the linear dynamic analysis in function of time and in function of the frequency. With the auto time step analysis, you can do analysis more quickly and gain a lot of time. Also, you can consider the random and the pre-stress conditions. Minus NFX has a large database for the seismic design criteria, which is very useful for the seismic design of the structures. And as you know, the software you are using may be good, but if it doesn't have this database, it's very difficult to do this kind of analysis. But fortunately here you have you have all you need. The nonlinear material supports the nonlinear contact geometry material, and you can use the large deformations, large rotation, follower force. You can use a lot of the type of contact, like the rolls, the friction, the general contact, and you can enter the parameters of your material directly into the software. You can use the composite materials. Also, you can see on the right here an experiment has been done in Japan. They have do the model and then done the tests in the real test, and what they found is really similar to the reality. Also, the explicit analysis is very important, and first it supports the very large deformation. Also, what is important to say is that when you want to do the impact analysis with some heat transfer or frequency response, you need to use another software, I mean in other softwares, and sometimes you have to do the modeling again. But in Midas NFX, it's very convenient. You don't have to use another software because all is integrated in one program. And you can consider the geometrical, material, contact, nonlinearity. It's very good. Also, functions which has been wanted by a lot of high-end users is contact separation. So when in your model the large deformation happened and the stress reached a certain value, the contact between the two parts can break, and so the two parts are separating one from the other. After, you can use also rigid materials to improve the performance of the calculation. You can also treat some problem very quickly with the multi-core interface of Midas NFX. Let me now present to you one of the new features of Midas NFX 2012, the multi-body dynamic analysis. You can now use several bodies into one analysis model. You can define some joints between them and define all kinds of movements. Also, you can use the rigid bodies and flexible bodies together to see the results you need only on the parts you are studying. And thus, you can gain precious calculation time. You can also use multi-body dynamics with linear analysis, modal analysis, but also with the nonlinear analysis like the explicit analysis. The second new feature of this Midas NFX 2012 is the topology optimization. So using this feature, the designer can let the Midas NFX design for him the best volume, complying with the designer's requirements. Also, you can add some manufacturing conditions to product easier your model. On the left is the model I used during the first demonstration. The part here has been designed using the topology optimization feature, and the design control was to reduce the weight by 45%. You can also compare the design obtained with the topology optimization and the original design, and you will see it's not exactly the same. Also here, you can use this topology optimization in frequency response analysis, and you can define a design condition like the displacement limited to 1.4 millimeter. There are also fatigue analysis, which is presented to this Midas NFX. You can perform all kinds of fatigue and durability analysis by using linear or multilinear SM curves, which are included also. We have also some options like the rainflow counting or the mean stress correction, which are provided also. You have multiple failure theory supported and several failure criteria. One of the most important issues of the CAE softwares is the calculation time, and thanks to Midas NFX and its powerful power solvers, you can carry all the analysis you need on large-scale models in very short times. Here you have this kind of time for these very big models, and it's all 200 seconds, 500 seconds, so it's really quick. Moreover, Midas NFX is reliable and has been used in several research theses. The benchmarking tests done on Midas NFX in comparison with other softwares gave some very concluent results, and you can observe that the difference observed in all these examples are very minimum, 0.1 0.01 millimeter in this linear analysis, 0.4 degree for this heat transfer analysis, and also 0.01 for this nonlinear contact analysis. So it's very reliable. I will show you now some of the pre-post process functions. The first one, as you have already seen into the demonstration, is the powerful cleanup function. In a few clicks you can delete all the small holes and fillets you don't need. And you can also use the manual deletion to suppress the manually more complex shapes like the chamfering around holes or the macro surfaces. The second feature is the automated contact definition, which is very useful, especially when you have large scale assemblies. And as you know, if the software you're using doesn't provide the automatic contact, then you may lose hours and hours of work just to define correctly the contacts. And in Midas NFX you have also a contact manager tool which help you to view all the contacts and their types more conveniently. After that you have the auto update of the analysis model feature, which is very interesting. I will show you very quickly into the software. In fact, you can open a template model, and on this template model some loads have already been assigned on each colored faces. And I will import two other models, and I will show you how it is easy to transmit the boundary condition and the analysis case to these models. Okay, let's show you in the same window the three models. Here I have the template model, and if I see the analysis case, three analysis cases have already been defined. One is the linear static, the model, and the nonlinear steady-state heat transfer. So to assign these cases to these parts I just opened, just have to drag and drop it on the model, and it will automatically assign it on my model. After that, I just have to, for example, to mesh the model very quickly. And now I can launch directly the analysis by right-clicking here, saving it somewhere, and it will automatically launch the calculation. So I didn't define the boundary, I didn't define the loads. All has been automatically assigned by using this template model and using the color faces. And you can view the results of this analysis. Okay, let's come back to the PowerPoint. Now, as you have seen, we have a parallel processing based high performance automatic mesh. All the parts are meshed at the same time, and you can even reduce this calculation time with a number of cores which are not limited into the software. You can use 1, 2, 4, 8 cores without problem. You can use the hybrid mesh, which, as you know, is the combination of the hexahedral and the tetrahedral elements, and it gives more accuracy to your model, and the calculation also is quicker. You have some functions like the macro. You can have a lot of post-process functions, like you can view the results into tables, you can trace some graphs, you can trace also graphs directly on your model. You can view the value of the elements of the mesh with the probe tool. You can also generate a report automatically. You have diverse post-processing graphics functions, like you have the divisive plot option. You can cut your model into to view what is going inside. Like in this thermal analysis, I'm mostly interested to know what is happening here. So I use this clipping plane option. You can use the vector plot or the virtual transformation. Also for the CFD, you can view streamline results to evaluate the fluid flows. You can view the flux, you can calculate the flux in a specific section of your model. We have also the moving mesh option for the mechanical fluid machinery. And as I've shown you also, we have the multi-body dynamic option. Okay, thank you very much for attending this webinar on Midas NFX. And you will have 20 minutes to ask all the questions you want. And I will answer them as much as I can. Okay, thank you very much, and see you on the next webinar.